CERN, everything you could possibly need to know about the Large Hadron Collider and what it means for humanity's future. The European Organization for Nuclear Research, known by its French acronym, CERN, is the largest particle physics laboratory in the world. Located just outside of Geneva, Switzerland, it was established in 1954 as one of post-war Europe's first joint ventures, with the express aim of halting the brain drain of talented scientists leaving the continent for America. Today, more than 10,000 scientists hailing from more than 100 countries find themselves at CERN each year to use its facilities, which include some of the biggest and most complex scientific instruments ever created. Their goal: figure out what the universe is made of and the laws of physics that dictate its behavior. What discoveries have been made at CERN? Highlights include the 1983 discovery of a pair of elementary particles called the W and Z bosons, which was later awarded the Nobel Prize for Physics. British computer scientist Tim Berners-Lee helped invent the World Wide Web at CERN in 1989 by developing a way for computers to talk to each other, called Hypertext Transfer Protocol, HTTP. In 1995, CERN scientists were the first to create atoms of hydrogen's antimatter counterpart, antihydrogen. In 2000, they discovered a new state of matter, a hot, dense, particle soup called quark-gluon plasma. And the Higgs boson was observed for the first time in 2012 at CERN's Large Hadron Collider, LHC, scooping its discoverers a Nobel Prize. What is the Large Hadron Collider and how does it work? The LHC is the world's most powerful particle accelerator, a giant machine that physicists use to smash tiny subatomic particles together at extremely high speeds to see what happens. The particle collisions recreate, for a fraction of a second, the conditions that existed moments after the Big Bang, when the universe was born. By studying the debris of these collisions, physicists try to settle mysteries such as what matter is made of and how particles get their mass. The LHC, which was completed in 2008, was built primarily to put the standard model of particle physics to the test. This wildly successful theory from the 1970s describes the interactions between the 17 elementary particles and 3 of the 4 fundamental forces of the universe: electromagnetism, the strong nuclear force, and the weak nuclear force. Gravity is the 4th. The standard model long predicted the existence of a never-before-seen elementary particle called the Higgs boson. After 4 decades of searching, in July 2012, physicists finally found it using the LHC. The discovery was a big win for fans of the standard model, but the theory is incomplete. It leaves many questions open, such as, what is dark matter? Why does the universe contain more matter than antimatter? The LHC may help answer these questions. The machine is buried deep underneath the France-Switzerland border near Geneva, in a circular tunnel nearly 27 kilometers long. It uses more than 1,035-ton superconducting dipole magnets, cooled to a temperature of -271.3 degrees Celsius, colder than outer space. The protons race around the 27-kilometer ring at almost the speed of light, completing over 11,000 laps per second. At 4 points around the ring, the 2 opposing beams are steered so that they cross paths. Where the beams intersect, the protons within them slam into one another and shatter into smaller particles. Most of the particles produced in the collisions are highly unstable and decay into more stable forms almost instantly. 7 enormous detectors, think of them as cathedral-sized digital cameras, are built around the 4 collision zones to capture data about these incredibly rare particles as they blaze briefly into existence. Why was the LHC turned off and is it up and running again? The LHC was initially switched on in September 2008, with a plan to run for at least 2 decades. The plan includes a handful of long shutdowns where the machine is turned off so that scientists can access the equipment, perform repairs and make upgrades that allow it to operate at higher energy levels, which means more potential discoveries, during the following run. The most recent long shutdown, LS2, began in 2019, and on April 22, 2022, the LHC was restarted after 3 years of maintenance work and upgrades, allowing protons to collide once again. What does the future hold for CERN? We spoke to Dr. Monica Dunford, the physicist responsible for coordinating research on the standard model of the ATLAS experiment, one of the 2 international collaborations credited with discovering the Higgs With this next run, we're expecting to get roughly double the total luminosity that we had by the end of run 2, says Dunford. Luminosity is how physicists describe the intensity of the particle beams. Doubling the luminosity doubles the likelihood of particles colliding. Last summer, Atlas announced the first-ever observation of 3 W bosons being produced simultaneously, from a data set taken between 2015 and 2018. Compared to creating a Higgs boson, triple W production is about 60 times less likely to happen during proton collisions. It's so rare a process that it makes us confident that maybe even in run 3 we could possibly measure Higgs self-coupling, says Dunford. A Higgs coupled to 2 others, a trilinear Higgs dash, is about 2,000 times less likely than a regular Higgs. Things could really start to get exciting after the next long shutdown, currently slated for 2026 to 2028. During that time, the LHC will be upgraded so heavily that it warrants a new name, the High Luminosity LHC, HLLHC. Over 20-plus years of operating, the machine will work up to generating luminosities nearly 30 times greater than those produced to date, allowing physicists to push the standard model to its limits. And the search for new physics doesn't end there. A proposed new collider, the Future Circular Collider, FCC, would dwarf the LHC. It's really just a concept right now, but ultimately this would be an even more powerful collider that would be 100 kilometers around, says Dunford. The LHC ring would basically just be the booster ring for the FCC. Thank you for watching. Please like this video and subscribe to Prison Planet if you found this information informative and entertaining.